Okay, so in this class, let us discuss about the Fourier transform. So here f is any real valued function, then the Fourier transform of f of x is defined by the integration from minus infinity to plus infinity f of x into e power I u x into dx. Now let us solve the first question. So we have to find the Fourier transform of this function. So first we need to draw this, we need to consider this, this is minus infinity and this is plus infinity, and we have to mark this a and b. If it is a, it is b, right? So if x is less than or equal to a, so that means in this portion your f of x will be 0, right? And in between a and b your f of x will be what? In this region, in this f of x will be 1. And after b, so x is more than or equal to b, so in this region f of x will be 0, right? So now let us split the integral by making use of the property. So let us consider the formula of the Fourier transform. Now let us split the integral from minus infinity to plus infinity as minus infinity to a, whereas f of x is 0, and a to b, whereas the f of x is 1, plus b to infinity, whereas f of x is 0. Right? So now, so this will become 0. Once the integrand is 0, 0 into e power I alpha x is 0. The whole thing is 0. So this is also 0. The remaining thing is this one. So now we have to calculate the integration of this. We all know that the integration of I u x is nothing but I u x divided by the differentiation of I u x with respect to x. So that is I into u, right? So we have to write the limits here. So this is the upper limit and this is the lower limit. Now we have to write upper limit minus lower limit. So let us substitute x equal to a and x equal to b here. Let me find the upper limit. Put x equal to b. So it is e power I u b divided by I u minus upper limit minus lower limit Put x equal to a. So it is e power I u a divided by I u. So the whole thing is, the answer is 1 by I into u. So that is e power I u b minus e power I u a. So now let us solve the next question. So find the Fourier transform of the function, right? So again we need to write the real line here from minus infinity to plus infinity, and we have to we have 0 here, we have to mark 0, and we have to mark this pi. So pi means 3 point something, right? So now, so in the region from 0 to pi, so in this region, so we have f of x equal to what? It is sin x, right? Other than f of x will be 0. So other than means in this portion your f of x will be 0, and in this portion your f of x will be 0, right? So now let us write the formula of the Fourier transform. So now we can split the integral from minus infinity to plus infinity as minus infinity to 0, 0 to pi, and pi to infinity. So now once the integrand is 0, 0 into e power I of x is 0, so the whole thing is 0. This is also 0, right? So we left with this only. So now we have to calculate the integration of this. To calculate the integration of this, we have a standard formula for this. So let me write that. So this is the formula. So here a equals to what? So here a equals to I into u, and what is b? So b equals to 1. So if I substitute that, so I will have, this is the integration, right? So I will have, so e power ax, so that is nothing but e power I u into x divided by a square, a equals to I into u. So I into u whole square is I square into u square, but I square equal to minus 1, it is minus u square, plus b square means 1, b equal to 1, so 1 square is 1. So into, so a into a means what? A equal to I into u, a into sin bx, that is sin x, minus b means 1, into cos bx, that is cos x. So this is the limit, right? So now, so let us calculate upper limit minus lower limit, right? So let me do that. So let me calculate the upper limit. Put x equals to pi. So e power I u pi divided by, so 1 minus u square into, so substitute x equals to pi here. So iu into sine pi minus cos pi. So this is the upper limit minus lower limit. Substitute x equal to 0 now. E power iu into 0, that is 1. E power 0 is 1 divided by 1 minus u square into, so iu into sine 0, right, minus cos 0, right. So now here sine pi is 0, so cos pi is minus 1, and again sine 0 is 0, and cos 0 is plus 1, right. So after the substitution of these values, so we have, so we can take 1 by 1 minus u square common. So this is the final answer.